There's a technique that is 3,000 years old, that needs no fertilizer, that needs no pesticides, that needs almost no extra water, and that produces food in an almost continuous way. And they don't teach it to you in any agriculture school. You won't see it on the most popular gardening channels. The garden centers don't recommend it. Why? That is exactly what we're going to discover today. But before I tell you what this technique is, I need you to understand something. Because what you are about to hear is not a modern theory disguised as ancient. It is not eco-marketing. It is something that entire civilizations use to survive, to prosper, to feed millions of people without a single bag of chemical fertilizer. And when you finish this video, you're going to look at your garden, your vegetable patch, your balcony in a completely different way. What I discovered when I started researching this left me with a question I could not get out of my head. How is it possible that we know so little about something that worked for so long? If you are the kind of person who believes that real practical knowledge has been quietly pushed aside, subscribe to this channel and hit the bell. We bring you the forgotten wisdom of how civilizations used to feed themselves before the industrial system owned them. The Mayan problem. Imagine you are in the year 1000 before Christ. You are in what we today know as Mexico, Guatemala, Belize. You are part of one of the most advanced civilizations that has existed on the American continent, the Maya. And the problem you have is a very real one. You have to feed an enormous population in a climate that can be brutal, with soils that deplete fast if you do not care for them well. You have no tractors. You have no synthetic fertilizer. You have no modern irrigation systems. You only have the land, the rainwater, and the knowledge that your ancestors left you. What do? Well, the Maya did something that today modern science is starting to truly understand. Something so simple that when you hear it for the first time you think, that cannot be enough. And yet it worked for 3,000 years. It still works today in indigenous communities throughout Mesoamerica. And it can work in your garden, in your vegetable patch, in any space where you want to grow real food. It is called the milpa, and it is exactly the three-plant technique that I promised in the title. The alliance, not the mix. But here comes the interesting part. And this is something most people do not understand when they hear about the milpa for the first time. It is not simply planting three things together. Anyone can do that. What makes the milpa special is the relationship between those three plants. It is an alliance, a system, an ecosystem designed with an intelligence that honestly makes us look pretty bad with all of our modern technology. The three plants are corn, beans, and squash. And before you think, I already know what he is talking about, I have heard this before, stay. Because what most people know about the milpa is the surface version, the two-paragraph Wikipedia version. What we are going to see today is the complete system, why it works, how it works, and why abandoning it was one of the biggest mistakes that modern agriculture made. Hit the like button if this is hitting something inside you. It takes 1 second, but it helps this video reach more families who deserve to hear what was hidden from them. The trap of monoculture. First, I need you to understand the problem that this technique solves. And for that, I need you to think about how conventional agriculture works today. The one that most people who have a vegetable patch use. Even if it is small, you plant one thing. You care for it. You water it. You add fertilizer because the soil alone is not enough. You put something against the pests because without that they eat it. You harvest. And the following year the soil is a little poorer than before. So you add more fertilizer. And the pests become a little more resistant. So you use something a little stronger. And the soil slowly deteriorates. And the cycle repeats year after year, season after season. This is not an accident. It is the logic of monoculture. Planting a single thing in a space over and over. And the problem with monoculture is that it goes against how nature works. Nature never does monocultures. Never. If you go to a forest, to a meadow, to any natural ecosystem, you see diversity. You see different plants coexisting, supporting each other, competing, balancing themselves. Nature is a system. Monoculture is the opposite of a system. It is the imposition of a single thing on a space that was designed to host many. And here is the uncomfortable truth that no one tells you when you start growing. Monoculture needs so much external support, so many inputs, so much intervention, precisely because it is unnatural. You are going against the logic of the soil, against the logic of ecosystems, against millions of years of evolution, and the soil charges you for it. The pests charge you for it. The water charges you for it. The Maya understood it without the need for scientific studies. They understood it by observing for generations, and what they developed was exactly the opposite of monoculture. Lucia's grandmother. Now let me tell you something. There's a woman named Lucia. She lives in a small community in southern Mexico, in Chiapas. She has a piece of land that is not big, about 500 square meters maybe. And for years she tried to cultivate it the way they told her. A row of corn, fertilizer, constant irrigation, something for the insects. The result was always the same, a more or less acceptable harvest, a soil that each year asked for more, and a bill for inputs that did not stop growing, until her grandmother, who was over 80 years old and who had cultivated her whole life the same way her parents and grandparents had, told her something that Lucia at first did not take seriously. She told her, "You are asking the earth for everything, and you are not giving it anything in return. The plants have to work together. Alone they cannot." Lucia took 2 years to listen to her. But when she did, when she planted her first real milpa following her grandmother's instructions, something changed. Not all at once, not in a dramatic way. But by the end of that first season, the soil looked different, darker, more alive, and the harvests were better than they had been in years, without having spent more on fertilizer. In fact, she had spent less. This is not magic. It is biology. And when you understand it, you cannot unsee it. The 3 roles. Let us go to the system, to the heart of what makes the milpa work. Corn is the first thing that is planted, and corn does something very specific in this system. It grows upward, fast, tall, and that turns it into the structure, into the support, into the skeleton of the system. Because corn is not there only to give corn. It is there to serve as support for the next plant. The bean comes after, and the bean is a climber. It needs something to climb, and the corn stalk is perfect. It wraps, it rises, it grows, and while it does something that no artificial fertilizer can truly replicate. It fixes nitrogen. The bean, like all legumes, has a relationship with certain soil bacteria that allow it to take nitrogen from the air, which is everywhere, but in a form that plants cannot use directly, and convert it into a form that the roots can absorb. It is literally a natural fertilizer factory integrated into the plant, operating continuously throughout the growing season. And this is something I need you to understand well, because it is fundamental. Nitrogen is the most important nutrient for plant growth. It is the one that depletes fastest in monoculture. It is the one that has to be replenished most with fertilizer. And the bean produces it for free, continuously, directly in the soil, right where the corn needs it. You do not need to buy it. You do not need to apply it. The system generates it on its own, but it does not end there, because the squash enters. The squash is planted on the ground around everything, and its leaves are enormous, wide, extended, and that has a very specific purpose, to cover the ground. The leaves of the squash create a dense layer that blocks direct sunlight on the soil, and that does several things at the same time. First, it blocks the growth of unwanted herbs. Without sunlight, the weeds cannot germinate or cannot survive. That means less weeding work, less competition for nutrients for the corn and the bean, less intervention. Second, it conserves moisture. Soil covered by squash leaves does not dry out as fast. Evaporation is dramatically reduced, and that means that with less water the system survives the same or better. In climates where water is a scarce resource, this is not a minor detail. It is the difference between a harvest and a total loss. Third, and this is what the fewest people know, the squash leaves, when they decompose at the end of the season, add organic matter to the soil. They nourish the earth. They leave it better than they found it. And there is something more. The squash has hairs on its stem and its leaves, small, almost microscopic. And those hairs create a texture that many insects find uncomfortable to move on. It is a natural defense against certain pests. No pesticides, No chemicals, only the plant doing what it evolved to do. You begin to see why this is not just planting three things together. Comment below if you have ever heard about the milpa before, even superficially, or if this is blowing your mind for the first time. I am curious to know how known this technique is among people who grow food, even in small spaces. The hidden world below. Let us return to the system, because there is one more layer in all of this that most articles and videos do not explain well, and that is the soil part. What happens underground in a milpa is in many ways more important than what happens above. When you plant three different species together, the roots of each go to different depths and have different structures. The corn has relatively shallow but extended roots. The bean has roots that go a bit deeper and that, as we said, have those nodules with nitrogen-fixing bacteria. The squash has roots that can go quite deep looking for water and nutrients in layers of the soil that the corn cannot reach. This means that the three plants do not compete for exactly the same resources. They are using different parts of the soil, different depths, different nutrients. They are not taking anything from each other. They are complementing each other. And the result is that the soil as a complete system is used efficiently, without being depleted, because no one is taking everything from the same layer at the same time. Now compare that with a monoculture of corn. Thousands of plants with the same type of root, at the same depth, competing for exactly the same nutrients, depleting exactly the same layer of soil season after season. Does it surprise you that it needs so much fertilizer? Does it surprise you that the soil deteriorates? And there is something else that happens underground in the milpa, something that modern science is just beginning to understand now in its full depth. The plants communicate through their roots, not the way humans communicate, of course, but there is a network of microscopic fungi called mycorrhizae that connects the roots of different plants and allows the exchange of nutrients and chemical signals. In a monoculture system, that network is limited. In a diverse system like the milpa, that network is rich, complex, efficient. The plants help each other in ways that we are barely beginning to map with science. The Maya did not know about mycorrhizae. They did not have microscopes, but they knew that the earth behaved differently when the three plants were together. They had seen it for generations. They had learned by observing, and they codified that knowledge in an agricultural practice that lasted millennia, the colonial mistake. Here comes something that I find fascinating from a historical point of view, and that I think says a lot about who we are as a society. When the European colonizers arrived in America, they found this system. They saw it. They observed the milpas. And instead of asking why it worked and learning from it, they discarded it. They called it primitive. They replaced it with European-style monocultures, with the systems they knew from their land of origin. And for centuries, that was a narrative. Indigenous agriculture was inferior. It was a thing of the past. The future was in specialization, in monoculture, in industrial efficiency. And what was the result? The result was the massive degradation of soils that had been fertile for thousands of years. The result was dependence on artificial fertilizers, on pesticides, on intensive irrigation systems. The result was that today in many parts of the world the agricultural soil is in such a deteriorated state that without external inputs it simply does not produce. We have created a dependence that did not exist before. Meanwhile, in the communities that maintain the milpa, in the indigenous peoples who never abandoned this practice, the soils continue to be productive. They continue to be fertile. They continue to produce without needing what the rest of the world needs. That is what 3,000 years of functioning means. It is not a slogan. It is an observable, measurable, real result. And this is where everything changes, at least for me, because understanding this made me ask myself something I think is worth asking. How much valuable knowledge have we discarded because it came from cultures we considered less advanced? How many solutions did we have, and we threw them away because they did not fit the narrative of progress we constructed? The practical application. Now, let us go to the practical part, because if you got this far, you probably want to know how to apply this. The first thing you need to understand, if you want to implement something based on the principles of the milpa, is that the order matters. The three plants are not sown at the same time. That is a common mistake many people make when they try to replicate this system without understanding well how it works. The corn goes first. It needs time to establish itself, to grow enough for the bean to climb up it. If you sow the bean at the same time as the corn, the bean grows faster at the beginning and can choke the young corn. So the corn needs a time advantage. Depending on the climate, that can be between 2 and 4 weeks. The corn goes first. You give it time so that it has at least 20 or 30 centimeters of height. And then you plant the bean. The squash goes after, or together with the bean, depending on the version of the milpa you are implementing. There are regional variations in how exactly the timing is organized, but the basic principle is that the squash comes after the corn. The distance between plants also matters. You do not plant too close or too far apart. The corn needs enough space to grow without competing excessively with those next to it. Around each corn plant or each small group of corn, you plant the bean and the squash. And here is something many people do not consider. The varieties you choose matter. The varieties of corn, bean, and squash that are used in the traditional milpa are heirloom varieties adapted over centuries to their specific conditions. They are not the high-yield hybrid varieties that you buy in any garden store. They are varieties that have co-evolved in a certain way with this form of cultivation. That does not mean you cannot do a version of the milpa with what you have available. You can, but if you can access heirloom varieties from your region, the system is going to work better. The soil also needs preparation. Not the chemical preparation we are used to, but a more basic preparation. Making sure that the soil has enough organic matter to start. If your soil is very degraded, you may need to add compost in the first season to give the system a viable starting point. But once the system is established, once the milpa is functioning, the system begins to regenerate the soil by itself. Each season it leaves it better than how it found it. This is what infinite harvest means in the title. Not that you are literally going to harvest forever without doing anything, but that the system, unlike monoculture, does not deplete its own substrate. It does not destroy the base on which it depends. It is a system that feeds itself, that sustains itself, that over time becomes more productive, not less. The philosophy of reciprocity. Now let us go deeper, because there is a dimension of the milpa that goes beyond agronomy, beyond the biology of the soil and the roots and the nutrients. And it is the cultural dimension, the philosophical dimension, if you will. For the Maya, the milpa was not just an agricultural technique. It was a relationship with the earth, with the plants, with the cycle of time and the seasons. The three sisters, as they are known in many Mesoamerican traditions, and also in indigenous cultures of North America, were not just crops. They were presences, entities with which the communities had a relationship of reciprocity. That idea of reciprocity is the one that impacts me the most when I think about this. The idea that you not only take from the earth, but you also give. That the agricultural system is not just an extraction. It is an exchange. That the earth feeds you and you care for it back. It is a radically different philosophy from the one that underlies modern industrial agriculture, where the earth is a resource that is exploited until it is depleted, and then another resource is sought or external inputs are added to compensate for what was destroyed. The philosophy of the milpa is that of the relationship sustained over time, not exploitation. Cultivation in the deepest sense of the word. And this is not just pretty philosophy. It has practical consequences. The civilizations that operated with that philosophy had sustained agriculture for millennia. The civilizations that operated with the logic of extraction have degraded soils in decades that took millennia to form. Modern soil science tells us that to form 1 centimeter of fertile soil, nature needs between 500 and 1,000 years. 1 centimeter. And in 50 years of intensive industrial agriculture, in many parts of the world, we have lost layers of soil that represent thousands of years of natural formation. And meanwhile, the soils where the milpa is practiced are still there. They are still fertile. They are still producing. Does that not tell you something fundamental about which of the two systems is more aligned with the reality of how the earth works? Scaling down to your space. Let us talk now about something that I find especially relevant for people who grow in small spaces, because the milpa is scalable downward. You can do a version of the system in a very small space. You do not need a field. You do not need much land. You need the principles. If you have a large balcony, You can plant corn in a large pot or a grow box. It is not going to be the giant corn of the fields, but it is going to grow. And around the corn, in the same box or in adjacent boxes, you plant beans. And on the ground of the box or in another box at ground level, you plant squash. Or even other cucurbits that do the same function, like cucumber or zucchini. It is not a perfect milpa. It is not the same as a milpa in a Mesoamerican field with heirloom varieties selected over centuries. But the principles are there. The complementarity is there. The logic of the system is there. And what you are going to notice if you do it is that the system takes care of itself more than you expected, that you need to intervene less, that the soil in that box at the end of the season is in better condition than at the beginning, that the pests are less problematic than in monoculture, not because it is magic, but because you are working with the logic of nature instead of going against it. The nutritional truth. There is another aspect of the milpa I want to touch on, and it is nutrition, because this is also interesting from a point of view of what we eat. The corn, the bean, and the squash together form a fairly complete nutritional combination. The corn contributes carbohydrates and some protein. The bean contributes good quality protein and complements the amino acids of the corn in a way that when consumed together, the nutritional quality of the protein is much greater than when consumed separately. The squash contributes vitamins, minerals, antioxidants, fiber. The civilizations that fed on the milpa as the base of their diet were not malnourished. The archaeological evidence suggests healthy populations with good bone density, with sizes comparable to or superior to those of contemporary European populations. The milpa as an agricultural system and the milpa as a food source were perfectly aligned with human needs. That is not an accident either. It is the result of thousands of years of refinement of a system that had to work well for people to survive and prosper. The resilience of the system. There is another dimension of the milpa we have not touched on yet. Its resilience to adverse climatic conditions. And this is especially relevant in the context of what we are living today. A monoculture is vulnerable. If a drought comes, if a specific pest comes, if the climate of a season is not the ideal one for that crop, you can lose everything. The dependence on a single species means that a single point of failure can destroy the complete harvest. In a milpa, if the season is not ideal for the corn, maybe the corn does not produce the maximum, but the bean can survive better. The squash can survive better. The system has redundancy built in. If one thing fails, the other two continue. And in agriculture, that resilience is not a luxury. It is literally the difference between eating and not eating. The Mayan civilization survived centuries of climate variability, of droughts, of adverse conditions. Not every year was good. Not every year the rains arrived when they had to arrive. And still, the system resisted, not because they were invulnerable, but because their base agricultural system had built in the capacity to absorb disturbances without completely collapsing. Today, with climate change making seasons less predictable, with rains arriving in different patterns, with extreme temperatures being more frequent, that resilience becomes incredibly valuable. The system that was designed to survive in variable conditions is the one that is going to keep working when the conditions are unpredictable. The final truth. I want you to stop a moment and think about this. There is a technique that is 3,000 years old, that was discarded 5 centuries ago as primitive and inferior, and that today, with all our scientific knowledge, we are rediscovering as one of the best available models for sustainable agriculture of the future. What does that tell us about our relationship with knowledge? About our tendency to assume that the newest is always the best? About how much we can learn from what existed before we arrived? The milpa is not just an agricultural technique. It is a lesson in intellectual humility, about the capacity to recognize that there is wisdom in places where we did not look for it, about the real cost of discarding what we do not understand. And it is also a concrete possibility. If you have a space to grow, even a small one, you can start to experiment with these principles today. You do not have to have a field. You do not have to be a farmer. You can have a grow box on a balcony and start understanding in a practical way what it means to design a system instead of simply planting one thing. There is something that happens when you do that. When you start to see your small growing space not as a collection of individual plants that you care for one by one, but as a system where the plants take care of each other. Your relationship with the cultivation changes. Your relationship with the soil changes. You start to observe in another way, to ask different questions. And those questions, over time, lead you to understand things about how nature works that no book explains as well as direct experience. The Maya learned that way, by observing, by testing, by refining generation after generation. And what they left as a legacy is a system that modern science is confirming with all its instruments and methods that works exactly as the indigenous communities always knew it worked. That is what 3,000 years means. Not just the technique. The knowledge, the deep understanding of the earth is not a resource that is exploited. It is a relationship that is cultivated. And when you understand that, when you really feel it and not only understand it intellectually, the way you relate to the earth changes forever. Whether you have a field, a small vegetable patch, or simply a pot on a window, if you got this far, it is because this type of content matters to you. Because you do not settle for the surface. Because you want to understand how things really work. And that is exactly what we keep doing here. Discovering what is underneath, what is not explained in 2 paragraphs. What deserves time and attention. If you want to keep discovering this type of thing, you already know what you have to do. Subscribe to the channel and share this video with someone you know who grows or has an interest in agriculture. Because this is exactly the type of knowledge that is lost when we do not share it. See you in the next one.